Welcome back to my channel. How to simplify math expressions. Math students are often asked to give their answers in the simplest terms. In other words, to write answers as small as possible. Though long, ungainly expressions and a short, elegant one may technically equal the same thing. Often, math problem isn't considered done until the answer has been reduced to simplest terms. In addition, answers in simplest terms are almost always the easiest expressions to work with. For this for these reasons, learning how to simplify expressions is a crucial skill for aspiring mathematicians. Method using the orders of operations. First, know the order of operations. When simplifying math expressions, you can simply proceed from left to right, multiplying, adding, subtracting, and so on as you go. Some math operations take precedence over others and must be done first. In fact, doing operations out of order can give you the wrong answer. The order of operation is terms in parentheses, exponents, multiplication, division, addition, and finally subtraction. A handy acronym you can use to remember this is please excuse my dear Aunt Sally or Pemdas. Method 1. Using the order of operation. Note that while basic knowledge of the order of operation makes it possible to simply to simplify most basic expressions, specialized techniques are needed to simplify many variables expressions, including nearly all polynomials. See method 2 below for more information. Second, start by solving all of the terms in parentheses. In math, parentheses indicate that the terms inside should be calculated separately from the surrounding expressions, regardless of the operations being performed within them. Be sure to tackle the terms in parentheses as your first act when you attempt to simplify an expression. Note that, however, within each pair of parentheses, the order of the operation still applies. For instance, within parentheses, you should multiply before you add, subtract, etc. As an example, let's try to simplify the life expression 2 times 2x plus 4, open and close parentheses 5 plus 2 plus 3 squared minus, open and close parentheses 3 plus 4 over 2. In this expression, we would solve the terms in parentheses 5 plus 2 and 3 plus 4 over 2. First, 5 plus 2 equals 7.3 plus 4 over 2 equals 3 plus 2 equals 5. The second parenthetical term simplifies to 5 because owing to the order of operations we divide 4 over 2 as our first act inside the parentheses. If we simplify went from left to right, we might instead add 3 and 4 first, then divide by 2, giving the incorrect answer of 7 over 2. Note if there are multiple parentheses nested inside one another, solve the innermost terms first, then the second innermost, and so on. Number 3. Solve the exponents. After tackling parentheses, next solve your expression's exponents. This is easy to remember because in exponents, the base number and the power are positioned right next to each other. Find the answer to each exponent problem, then substitute the answers back into your equation in place of the exponents themselves. After dealing with the parentheses, our example expressions is now 2 times 2x plus 4 times 7 plus 3 squared minus 5 The only exponent in our example is 3 in the second power, which is equals to 9. Add this back into the equation in the place of 3 squared to get 2x plus 4 times 7 plus 9 minus 5. Number 4. Solve the multiplication problems in your expressions. Next, perform any necessary multiplication in your expression. Remember that your multiplication can be written several ways. A X symbol, a dot, or an asterisk are always ways to show multiplication. However, a number hugging a parenthesis or a variable like 4, 4 closing or parenthesis x also denotes multiplication. There are two instances of multiplication or problem. 2x open parenthesis 2x is 2 times x close parenthesis and 4 close parenthesis 7 and open parenthesis. We don't know the value of x, so let's leave 2x as it is. 4 times 7 equals 4 times 7 equals 28. We can rewrite our equations as 2x plus 28 plus 9 minus 5. 5. Move on to division. As you search for division problems in your expression, keep in mind that, like multiplication, division can be written multiple ways. This, the simple divisor symbol is 1, but also remember that slashes and bars in a fraction, like 3 over 4, for instance, signify divisions. Because we already solved a division problem, 4 over 2, when we tackle the terms in parentheses, our example no longer has an division in it, so we will skip this step. This brings up an important point. You don't have to perform every operation in the Pemdas acronym when simplifying an expression, just the ones that are present in your problem. Number 6. Add. Next, perform any addition problem in your expression. You can simply proceed from left to right through your expression, but you may find it easiest to add numbers that combine in simple, manageable ways first. For instance, in the expression 49 plus 29 plus 51 plus 71, it's easier to add 49 plus 51 equals 100, 29 plus 71 equals 100, and 100 plus 100 equals 200, rather than 49 plus 29 equals 78. 78 plus 51 equals 129, and 129 plus 71 equals 200. Our example expression has been partially simplified to 2x plus 29 plus 9 minus 5. Now we must add what we can. Let's look at each addition problem from left to right. We can add 2x and 28 because we don't know the value of x, so let's skip it. 28 plus 9 equals 37. So let's rewrite expression as 2x plus 37 minus 5. Number 7. Subtract. The very last step in PEMDAS is subtraction. Proceed through your problem, solving any remaining subtraction problems. You may address the addition of negative numbers in this step, or in the same step as the normal addition problems. It won't affect your answer. In our expression 2x plus 37 minus 5, this is only one subtraction problem. 37 minus 5 equals 32. Review your expression. After proceeding through the order of operations, you should be left with your expressions in simplest terms. However, if your expression contains one or more variables, understand that the variable terms will remain largely untouched. Simplifying variable expressions requires you to find the values of our variables or to use specialized techniques to simplify the expression. Our final answer is 2x plus 32. We can address this final addition problem until we know the value of x. But when we do, this expression will be much easier to solve than our initial lengthy expressions. I'd like variable terms, simplifying complex expression method number 2. First, I'd like variables terms. When dealing with variable expressions, it's important to remember that terms with the same variables and exponents are like terms, can be added and subtracted like normal numbers. The term must not only have the same variable, but also the same exponent. For example, 7x and 5x can be added to each other, but 7x and 5x squared cannot. Number This rule also extends to terms with multiple variables. For instance, 2xy squared can be added to negative 3xy squared, but not negative 3 squared y or negative 3y squared. Let's look the expression x squared plus 3x plus 6 minus 8x. In this expression, we can add the 3x and negative 8x terms because they are like terms. Simplified, our expression is x squared minus 5x plus 6. Simplify numerical fractions with dividing or cancelling out factors. Fractions that have only numbers and no variables, and both the numerator and denominator can be simplified in several ways. First, and perhaps easiest, is to simply treat the fraction as a division problem and divide the numerator by the denominator. In addition, any multiplicative factors that appear both in numerator and denominator can be cancelled because they divide to give the number 1. In other words, if both the numerator and denominator share a factor, this factor can be removed from the fraction, leaving a simplified answer. For example, let's consider the fraction 36 over 60. If you have a calculator handy, you can divide to get an answer of 6. If you don't, however, we can still simplify by removing common factors. Another way to think of 36 over 60 is 6 times 6 divided by 6 times 10. This can be rewritten as 6 over 6 times 6 over 10. 6 over 6 equals 1. So our expression is actually 1 times 6 over 10 is equals to 6 over 10. However, we're not done yet. Both 6 and 10 share the factor 2. Repeating the above procedure, we are left with 3 over 5. Number 3, in variables fractions. Cancel out variable factors. Variable expressions in the form of fractions offer unique opportunities for simplification. Like normal fractions, variables fractions allow you to remove factors that are shared by both the numerator and denominator. However, in variable fractions, these factors can be both numbers and actual variable expressions. Let's consider the expressions 3x squared plus 3x over divided by negative 3x squared plus 15x. This fraction can be rewritten as x plus 1 times 3x divided by 3x times 5 minus x. 3x appears both in the numerator and in the denominator. Removing these factors from the equations leaves x plus 1 divided by 5 minus x. Similarly, in the expression 2x squared plus 4x plus 6 divided by 2. Since every term is divisible by 2, we can write the expression as 2 times x squared plus 2x plus 3 divided by 2, and thus simplify to x squared plus 2x plus 3. Note that you can cancel just any term. negative, you can only cancel multiplicative factors that appear both in the numerator and denominator. For instance, in the expression x times x plus 2 divided by x, the x cancels from both the numerator and denominator, leaving x plus 2 divided by 1 is equals to x plus 2. However, x plus 2 divided by x does not cancel 2. 2 over 1 equals 2. Number 4, multiply parenthetical terms by their constants. When dealing with variable terms in parentheses with an adjacent constant, sometimes multiplying each term in the parentheses by the constant can result in a simpler expression. This holds true for purely numeric constants and for constants that include variables. For instance, the expression 3 times x squared plus 8 can be simplified to 3x squared plus 24, while 3x times x squared plus 8 can be simplified to 3x cubed plus 24x. Note that in some cases, such as in variable fractions, the constant adjacent to the parentheses give an opportunity to cancellation and thus should be multiplied through the parentheses. In the fraction 3 times x squared plus 8 divided by 3x, for instance, the factor 3 appears both in the numerator and the denominator. So we can cancel it and simplify the expressions to x squared plus 8 divided by x. This is simpler and easier to work with than 3x cubed plus 24x divided by x, which would be the answer would get it if we had multiplied through. 5. Simplify by factoring. Factoring is a technique by which some variable expressions, including polynomials, can be simplified. Think of factoring as the opposite of the multiplying through parentheses step above. Sometimes, as an expression can be rendered more simply as two terms multiplied by each other. Rather, let's consider the expressions x squared minus 5x plus 6 once more. This expression can factor to x minus 3 times x minus 2. So if x squared minus 5x plus 6 is the numerator of a certain expression, which one of these factors terms in the denominator? Like is the case with the expression x squared minus 5x plus 6 divided by 2 times x minus 2. We may want to write it in factored form so that we can cancel it with the denominator. In other words, with x minus 3 times x minus 2 divided by 2 times x minus 2, the x minus 2 terms cancel, leaving us with x minus 3 times 2. Then, as one of unified expression, this is especially true if factoring in an expression allows you to cancel part of it, as you would it in fraction. In special cases, often with quadratic equations, factoring even allows you to find answers to the equations. As hinted at above, another reason you may want to factor your expression has to do with the fact that factoring can reveal answers to certain equations, especially when those equations are written as expression is equal to 0. For instance, let's consider the equation x squared minus 5x plus 6 equals 0. Factoring gets us x minus 3 times x minus 2 equals 0. Since any number times 0 equals to 0, we know that if we can get either of the terms of parentheses to equal 0, the whole expressions in the left side of the equal sign will equal 0 as well. Thus 3 and 2 are two answers to the questions. Thanks for watching. Don't forget to subscribe.